So I'm going to tear down a drive motor out of a T300 for you. It's a T300 Bobcat, just like the one behind me. What we're going to do is a tear down and kind of a failure analysis of this drive motor, kind of give you an idea of what typically fails and what you're going to find inside when you tear one of these apart. I've got two different motors actually we can look at, where this one is going to be a short nose or short shaft motor. I've also got a long shaft motor, and I'll show you the difference between those. If you have a short shaft drive motor on your T300 or 250 or whatever the case may be, this is kind of an outdated style. Bobcat doesn't really even support this anymore, so if you were to get a remanufactured motor or something, if this wasn't rebuildable, remanufactured from Bobcat, you're probably going to upgrade to the long nose drive motor, and you would have to upgrade your sprocket as well. You have to have a deeper sprocket to offset that length of that bearing hub section there. So let's go ahead and tear into this one real quick, and we'll talk about what the typical failures are and the symptoms of this drive motor itself, why we pulled it out. So let's tear into it real quick. So on the short shaft drive motor, what we can do is we can, measure from the mounting flange itself to the face of the hub, and we'll find that we have 5 3/4 inches on the short shaft, and then this would be a long shaft motor here, and from the mounting flange to the end of the or the surface of the hub, 7 inches. So that's how you tell the difference: 7 inches versus 5 3/4 inches. We can look at this motor in 3 different sections. We got our brake section out here, our piston, our actual drive section, and then our hub section here. So we always start tearing down the motor from the brake section itself. The symptoms of this particular motor was you would start to drive and it would lock up, and you could tell that the pump on the left side of the machine had plenty of pressure. You push the stick, you can hear the pumps really trying, but it's like the brake was stuck on this, and that's what was going on. So we troubleshot it down to the drive motor, we pulled it off. So let's tear into it and see what we find here. Like I said, we have to pull all these bolts out of the end cap here to get to our brake piston. So I don't know if you can see or not, but I haven't even finished tearing in, taking this cover off, and we have oil starting to drip out of this cover plate. And I'll pull this cover off, and we've got a brake spring right here. So this is our cover. That's what this big wafer is this is an actual spring that this piston pushes apart. So it's to release the brakes on this machine, we have hydraulic charge pressure that comes into this port here. And what that does is that pushes this piston against this spring, and it releases the brake pack inside of here. So when the machine's not running, of course, you don't have charge pressure, so this spring pushes this piston back onto the brake pack, and that's what locks your brakes. Hydraulically released, spring applied. So this gasket out of our way. This is our brake piston here. Hopefully we can see that. And like I said, so we got oil here on the top of it, and there should not be any oil on top of this because there's a brake seal here. And what happens now, our charge pressure oil is trying to push the piston this way, but oil is bypassing the seal. Now it's getting on top of the piston. So 2 things that can either not allow enough charge pressure to push against that spring and release the brakes, or enough oil gets in between here and this plate, and it acts like a hydrolock. I mean, you can't force that fluid against this plate and push that piston. I mean, I've seen actual plates bowed out, ballooned out, because there's so much pressure from this piston pushing against this plate, it actually balloons it out. Like, it's kind of like hydroforming, right? So this is the most common failure on these is the seal on this brake piston goes out, oil gets on top, your brakes can no longer release, and a lot of times it's such a slow effect you don't realize it. It feels like your motor's getting weak, but what you're doing is you're driving against the brakes in there and you're just grinding them down, and then you're going to start sending metal all through your system. You're going to clog up your K-string filter. Then once your K-string filter is clogged up, then you start blowing seals. So let's see if we can get this brake piston out and take a look at it. So we can actually put a bolt in the center and we can pull it out. But I usually like to put just a little bit of air pressure into this brake port. Try not to blow oil all over ourselves when the piston comes out. And see, that's just pushing that piston right out there. And here's our brake piston, and here's that seal that I was telling you about that goes bad. And like I said, you don't really even know that it's happening until it's too late. One thing we notice right away when we pull this out, that's all metal. That's your great brakes grinding together, trying to drive through the brakes there. So, you know, we have to inspect this shaft here on the end of the piston, and it looks decent. So no major damage to the piston itself, so that's savable, that's good. However, when we look down inside here, again, it's just full of metal. So, you know, not a huge deal, but we'll keep tearing into it and see what we can find. And there's also a bushing right here that brake piston slides into. This is a bronze bushing. We have to check the condition of it, see if we need to replace it or not. And there's a lot of bronze and metal in there, so I will replace that bushing as well. So now we're going to pull our brake piston housing off itself with a big Allen key. So just chunks of metal coming out of, see, these are a brake disc here. Kind of looks like a clutch. We're gonna have to dig these out, but you can see this one's broken and see it just metal to metal. And that's typically what happens when we lose that brake seal piston. I mean, you know, a lot of people replace a $5,000 motor. Well, I say $5,000. You know, you can get them remanned for, these motors are about $2,500. I don't even know if you can buy them new anymore. If you can find one, that'd be, you know, an option. But yeah, see, so these are brake discs. We'll replace the entire brake pack, and on the end we have shims because we have a measurement that I can't even get the rest of those out right now, but we will stack these in and we'll do a measurement here, and then we will shim them to get the right clearance, you know, or right thickness of our brake pack. And so that's, I could probably just rebuild this end section right here and be just fine with this motor, because a lot of times you lose your hub section here if you don't change your hub oil. But the hub's not leaking on this, but we still need to keep going inside and see if there's any other damage. But right now we know that the brake piston seal failed and our brakes were grinding metal to metal, so that's why our brakes wouldn't release. So that explains the symptoms of why the machine wouldn't drive. So far I don't see any damage to the housing, so it's definitely savable. Oh, here comes the rest of our brake disc. Yeah, just metal to metal grinding. Yeah, check that one out. Real nice, Clark, real nice. There's what's left of another one. And you know, sometimes this is why we opt to go with a, you know, remanufactured motor, because by the time we do seal kits and start putting the parts in it, especially if you lose a hub section, it's almost not worth rebuilding. But I know it's hard to see, but see, we got the splines here where one brake disc locks into these splines, and then the inner brake disc locks onto these splines, and these are really tore up in here. So we could probably clean those up and save this outer section, but we may have to get a brake section. We might have to replace this brake section, but once we get it cleaned up, we might be able to file those down and save it, but we won't know till we get further in there. And then this is going to be our brake drive shaft that's splined inside. And then this is splined too, where the brake disc, see, this is being an internal brake disc with splines on that one, so that'll be on our internal shaft, as opposed to the brake disc with the splines on the outside. So that's how they stack, is you'd have one internal, one external, and then we stack those up to measurement, and those get sandwiched in, and that's how they work on the splines on the outer hub that we already took off. So I don't know, hopefully that kind of makes sense. So now we're going to pull off this section and we're going to inspect our piston drive in here. So we're going to get this thing set up a little differently. So I finally got the bolts out of my distributor section, so now we're going to lift this off. This piece right here is our distributor. We'll look at that here in just a second. And here's our piston group right here that we're looking at, and you can see that this right here, this motor could be used for an SJC system with a speed sensor. That's what this reluctor ring right here is. And you know, on our distributor section somewhere on here, where'd it go? Back over here, it's got a plate, and that's where the speed sensor would go, right here at this plate. But this system doesn't use it's just a universal motor. We don't have a speed sensor, but if it did, this motor would work. Ugh. So we're inspecting the ring. These little humps and valleys here is what our rollers, our piston rollers, run on. And we'll talk about the timing here in just a second. It can get kind of complicated, but that's what the distributor we just looked at is for. We want to make sure that it fires correctly. But again, we'll get to that in a minute. Oh man. Okay, then here's our piston assembly here, and each one of these pistons that slides in and out has an O-ring inside there, and that's you know, when we rebuild this, we'll replace the O-rings. But we really want to inspect our rollers here, make sure there's no wear on our rollers, along with inside the ring there. These holes here is where the distributor sits. Let's pull out the distributor real quick so you can kind of see how this works. So I can't get the distributor out right now, but I do want you to see this. See, these holes in the distributor, that's when our oil, our pressure's coming in. As this rotates, oil flows from this hole from the distributor into one of these holes, and it's timed. I don't know exactly which one is pushing oil, but what's important to know is oil comes out of here and into here, and this distributor is timed. There's a key up here that keeps this thing perfectly centered where it's at. And what happens if that pin starts to get worn or egg-shaped, this distributor could start to move a little bit, and then the timing will get off. So this piston will fire when it should be just as it starts to come down one of these ramps. If it fires too soon, of course, it would try to lock it up, and it fires too late, then you're losing power. So that's why it's important for that distributor to be timed, which it's got a timing pin. You can't mess it up. You just want to make sure that the pin's not warmed and the hole in the top of the distributor is not egg-shaped. And it's kind of like the distributor on your car, right? 1 or 2 degrees of timing can make a big difference, and here it's less than that. And so watch, we put a little air pressure in this hole right here. See how that piston shoots out right here. So that one moves out. So you see those move out. So putting air pressure in there, it kind of shows you that's what the hydraulic oil is doing. It's, you know, it's letting oil come back when it starts to go up the ramp, and it pushes oil in as it goes down the ramp. So hopefully that kind of makes sense, but everything in here looks really good. So I'm gonna set my distributor section off to the side. And our piston section. Now I got two large snap rings on either side here that we'll remove, and when you remove those snap rings off this outside, that's what allows us to take these pistons off so that we can reseal the pistons, or if we have to change rollers. Or we're going to completely disassemble it and clean it anyways, but that's how you get those rollers out. And then all we're left with is the hub section. Now, the hub section, I guess real quick, I'm not going to tear it down because I believe this hub section is good. I say it's good. I might tear it down anyways, but this bearing is lubricated with hydraulic oil. The outer bearing is a hub oil, and we'll change that hub oil through this pin right here. Or on your longer shafts, you know, they say you have to remove your track and your sprocket, and you'll have a bolt on top and a bolt on bottom, and you'll pull those off and drain the oil and replace the oil. But yeah, so the hub section, you got an inner and outer bearing on the section, and that's why they went to the long shaft, because now you got more support for that that hub shaft with the bearing when they spread them out, and it's got a heavier duty bearing as well, so that's why they last longer. But anyways, hopefully that makes sense. That's kind of the teardown of it real quick, the nitty gritty. But yeah, stay tuned, and I think we're going to rebuild this motor and get it back in our 300 instead of trying to buy a reman. Now the seal kits are really expensive. That's why I like to tear it down and inspect it first, because if we buy a $700, $800, $1,000 seal kit, and then we tear this down and find out the motor's bad, then you know what I mean. So tear it down first, then order your kit, and stay tuned, and we'll get this thing put back together. Thanks for watching.